Hey guys! So I'm re-recording the 1.06 lab because I know it went silent on the old recording I had. So this is for the relative humidity lab, 1.06 in earth science. We're gonna start off by getting materials together for you. So I'm gonna screen share. And we're going to start by getting the materials that you would need inside your classroom. So go to Earth Science and wait for everything to load. If you are on track with things, you'll be able to get there from the class plan, but as many of you will probably get to this maybe later, just because I know you're waiting for kits and things. You go to Unit 1 in that course content bar. You're going to scroll down and choose 1.06. All right, so this recording will be here. Obviously, you have to already be watching it to get that, but since you found the recording and you're watching this, next thing you're gonna do is go into lesson introduction. So in lesson introduction, on the third page, and this is for any lesson here, on the last page of the introduction, there's always gonna be something called student guide. For normal lessons, this is great for helping guide your notes. For labs, you definitely need these because these have your procedure. Okay, they also have some useful keywords. Some of these might come in handy for your lab write-up. Please put it in your own words though. And lo and behold, procedure. Okay, so make sure you have that student guide. Then we're gonna go back to the tab we were on. And even though this is a discussion assignment, I want you to grab the LRD. I think this is where the diagram is that you need to determine your relative humidities. Enable editing makes it easier to scroll through. Yes. So this chart here is something you're going to need in order to actually do something with the numbers that you get. So I'm going to explain to you in a little bit how to get there. This table is also helpful. All right. The other questions, you don't have to worry about them, 3 and 4, because those aren't part of your discussion. You're more than welcome to answer them, but it's not something you're turning in. But this chart here, all these numbers, and this table are going to be helpful for making sense of the values you get off of your thermometers. All right. So, physical materials, you need 2 thermometers. These are in boxes in your kit. Okay, I think you should have at least 3 total in your kit, but you only need 2 for this lab. You need some paper towel, which I have these sitting on. And if you have a handy fan around, that is really hard to see. But if you have a handy, just small handhold fan, that's going to be great. But you can also manually fan off one of the thermometers. Just use, your earth science book and slide it back and forth across the wet bulb thermometer. All right, so setting up your lab. First off, as much as it might be tempting, don't try to take the thermometer out of here. All right, it's really tight. You're probably going to break it trying to do it. The lab should still work just fine, even with the plastic casing. Plus, if you take the thermometer off, you can't read the temperature anymore. So one of these you're going to leave alone. You're not going to do anything to it. This is your dry thermometer or dry bulb. The other one, you're going to take your paper towel. You're going to wrap it around the bottom of the thermometer, so around the bulb. All right, so I'm just going to go like this. Let's see, I'm going to make that a little bit smaller. So your bulb is in the little like lines down here, so that's where you want to focus on covering it. And just wrap it around. If you have a rubber band or tape or something, you can tape it so that it stays, but once you get it wet, it should kind of stay anyway. Now, there are little droppers in your kit. You can use this, or if you can be near a sink, use a sink. So get the water going. Let's see if I can get you actually in the sink, kind of. So get your water going, kind of. Slow trickle here. And you're going to get the paper towel soaking wet. Okay? So again, once you kind of get the back wet, it sticks and holds a little better. You want to get it to the point where the water, if you kind of press on it, it starts to squeeze out. So it's nice and saturated, very wet. All right. Then let's look at your procedure to see exactly what we're going to be doing as far as recording temperatures. Okay. So here's securing the small piece of cotton bulb. I used paper towel. That's fine. Wet the cloth till it's saturated. Record the temperature of both the wet bulb thermometer and the dry bulb thermometer in your data table. Alrighty. So my dry bulb thermometer says 22 degrees Celsius. Now, here on the table, I'm noticing it says after fanning, so I feel like I missed a step in the procedure. Okay, so we're just kind of recording a starting temperature, because right now they're the same. So I'm just going to put this up top here. Both started at 22 degrees Celsius, because in the table, we're actually putting the after fanning numbers. So if you look at your procedure, it says, make a hypothesis about the temperature that each thermometer will register after you fan them. Will they continue to have the same reading or one of them will be lower? If so, which one? Write your hypothesis in the space provided. All right, so that means I'm gonna let you do that part because hypothesis is a prediction. There is no right or wrong hypothesis. But the next thing that you do is fan the wet bulb thermometers. So what I'm going to do to make sure that I'm just fanning the wet bulb, I'm going to take my dry bulb thermometer and put it on the other side of my computer so that it's nowhere near the fan. So, and then I'd let it go for, 5 minutes or so. Or you can watch the temperature, and if you start seeing something happen, keep the fan on it until it stops. You should see something happen. Trying to think if So again, if you have the electric fan, it'll make life easier, but if you have to do this manually, that's fine. It's not going to be the end of the world. Now, fast forward, pretend that I actually have my results, because you do need to let it go for probably at least 5 minutes or so. More than likely, your dry bulb should stay the same because you're not doing anything to it. Your wet bulb, probably going to decrease. So, the difference between the two is 2 degrees Celsius, and this is where the chart comes in. So if you see on the chart, the column or the rows are the dry bulb temperatures. So we're eventually going to go down to 22 degrees Celsius because that's our dry bulb temperature. The columns are identified by the difference between wet and dry bulb. Okay, so the column we're going to be focusing on is this column with 2 at the top. So we're going to go down until we get to 22 degrees Celsius. Oops, I left the table. Right here. So that means that our relative humidity in the room is 82%. So probably my made-up numbers here aren't right because I am in Phoenix. I doubt the relative humidity is actually 82%. But this is just to show you how to read the table. And again, this is why you're going to do 3 trials instead of 1, because you might get wonky data on one of them. Something to keep in mind though, between trial 1 and trial 2, make sure your paper towel is still wet. So you might want to run it under the sink again. Last thing for the discussion assignment. So I'm going to go back to our main area here. 1, I would read this learn relative humidity so that you have a good handle on what relative humidity is. And then when you get to the discussion assignment, make sure you do everything that is listed in this prompt. Okay? So it says review the data you collected in the lab. Define relative humidity. Make sure you do that. So again, that's why you want to read the learn relative humidity. Write a hypothesis that explains the relationship between humidity and dew point. All right. In live class on August 4th, we covered how to get through the assignments for the 1.05 and 1.06 labs. So if you're struggling with this, watch that recording. So, and then in the discussion board, you're going to share this definition of relative humidity. You're going to share your hypothesis. You're going to share your data. So share those average numbers you get at the end. And then, because you already shared your hypothesis, you're going to make a conclusion. Was your data supportive of your hypothesis? Did it match what you predicted? Or did it not match? Okay. And the last thing you do, you got to respond to at least one classmate. All right. If your classmates are missing something, help them out. Suggest, give them some hints on how to get in what they need. Okay. All right. So that is the presentation here. Looks like I still have volume at the end, so I think this all worked. Good luck.